Hello folks, welcome to Samarth Academy. In today's video we'll be talking about trigonometric identities, trigonometric values and some exam relevant questions. Today's video is going to be important for this topic because I'm going to also talk about a few tricks to learn the values of various trigonometric ratios. Okay, so let's begin. First up, let's talk about the identities. So there are three type of identities basis which all the other formulas and all the other identities are created. Okay. So first set is called reciprocal identities, which basically means that we only need to consider three basic ratios: sine, cos, and tan. Using these, we are able to calculate the value of cot, cosecant, and secant whenever needed. Okay. So as far as values and how they behave in each quadrant is concerned, we primarily focus on cos, sine, and tan. Basis that we are able to derive what cot, cosecant, and secant would look like. Okay. Second set of identities is related to Pythagorean. So these are derived from the fact that hypotenuse square is equal to perpendicular square plus base square. Right. The identity which was given by Pythagoras. Using this, we are talking about these sine square plus cos square is equal to 1, the basic identity. Then there are two more, one related to tan and secant square, other related to cot and cosecant square. Okay. Then third set is, which is nothing but simplifying tan and cot into their basic form of sine and cos. Okay. So primarily sine and cos are the two basic ones, and then tan is another one which we can consider as basic. But while solving cot and tan questions, we usually tend to even simplify tan and cot into sine by cos and cos by sine respectively. Okay, let's move on. Now comes the trigonometric values. So here in this chart we can see the values of various trigonometric ratios at some common acute angles, right? So 30, 45 and 60 are the ones which we tend to remember because at 0 and 90 they are at their extremes, right? For example, sine starts at 0 ends at 1, so we know 0 and 1. Cos starts at 1 ends at 0, so we know that one. But in the middle, these are the values which we tend to remember. Okay. So here let me talk about some memorization techniques, right? And usually what we tend to do is to remember the first one which we were ever taught. So I'm also going to be talking about that one. However, for me it has worked thus far, so I'll suggest that if you are struggling to remember the values and the definition of various ratios, you can try and use this one, and if it works then all the same, right? So for definition purposes, sine, cos, tan, what I tend to use is p, b, p, h, h, b. So p by h is sine, b by h is cos, p by v is tan, where p, b and h stand for perpendicular base and hypotenuse respectively. Okay. So in Hindi there's a acronym which was taught to us by our physics teacher, Pandit Badri Prasad Har Har Bole. So yeah, these acronyms tend to be silly, but yeah, mnemonic devices are supposed to be that way usually, right? Pandit Badri Prasad, what did he say? Har Har Bole, because he's a religious nut, right? Alright, so as far as values are concerned, we have a repetition there as well, right? So it'll be 1 1 root 3, 2 root 2 and 2. 1 1 root 3, 2 root 2, 2. Okay. Similarly for cos, but starting with 60, 1 1 root 3 2 root 2 2. Okay, so cos is this, and then for tan 1 1 root 3, and then in reciprocal we'll have 1 1 root 3. Okay, so that's kind of the device which I tend to use. I hope this helps you as well. 1 1 root 3 2 root 2 2, 1 1 root 3 2 root 2 2, and then 1 1 root 3 1 1 root 3. Okay, all right, let's move on. So here we'll see some of the questions which have been asked in the exam, which simply use these concepts and are fairly quick to solve as well. Okay, first one, what is the value of secant square minus tan square? Right, so secant square is equal to 1 plus tan square is an identity, right? This one right here, this is the identity. So the question which is asked is simply another form of this. So secant square minus tan square is equal to 1. Okay, so this is the question which was asked in 2012. Then if cos a plus cos square is equal to 1, what is the value of 2 sine square a plus sine to the power 4a? So cos a is equal to 1 minus cos square a, cos a is equal to sine square a, right? Let's use this to solve this. So the expression is 2 sine square a plus sine 4a, right, which can be written as cos a plus sine square a whole square, which is cos a plus cos square a, right? So the overall value becomes 1 multiplied by 2, which is 2. Okay, moving right. If tan 8 theta is equal to cot 2 theta, where 8 theta is less than 90 but more than 0, then what is the value of 5 theta? So tan and cot are equal only once, right? And we can also convert this cot 2 theta into tan 90 minus theta, right? So that is the conversion of allied angles. So sine 90 minus theta becomes cos theta, and cot 90 minus theta becomes tan theta. Okay, so this becomes cot 90 minus theta is equal to tan theta, which implies 8 theta is equal to 90 minus 2 theta. So theta, we get the value 9. Basis this, we can simply calculate tan 5 theta, which is 45, and at 45 tan is equal to 1, right? So simple 30-second question which is already been asked in the exam. Moving on, if sine theta plus cos theta is equal to root 3 by 4, then sine to the power 4 plus cos to the power 4 is equal to, okay, so the required expression is root 3 by 4, and sine theta cos theta can be converted to sine 2 theta, right? So sine 2 theta becomes root 3 by 4 into 1 by 2 into 2, because you had to take another 2 here to make it 2 theta. What is the formula for combined angle? Sine 2 theta is equal to 2 sine theta cos theta, right? So we had to take another 2 here and then cut it off, so value becomes this. So time at sine 2 theta value is 3 by 2, which means sine 2 theta is equal to 60 and theta is equal to 30. So if we solve by putting the value, sine 2 theta, sine to the power 4 cos to the power 4, at 30 sine is 1 by 2, cos is root 3 by 2, to the power 4 we get 1 by 16 plus 9 by 16, solving we get 5 by 8. Simple enough. There's another alternate method of solving this one as well, using the identity, right? So if we convert it to sine square whole square plus cos square whole square minus 2 cos square sine square plus 2 cos square sine square, then that would become the identity, and we'll be able to solve using that as well, simply substituting the value of sine theta cos theta in the equation. Okay, so yeah, we have alternate method of solving. That's fine. All right, folks. So in today's video, this is it. Hope this gave you a perspective on where you stand with regards to your preparation, and also some clarification on the concept of how to memorize the values of ratios. Okay. From an exam perspective, this is a very important topic, so please do pay adequate attention to this one. Have a good rest of the day. Bye bye.